Now we are going to learn about Newton's second law for a solid in rotation. Newton's second law for a solid or a particle in translation is expressed by this relation. The cause of this motion produces an acceleration. The force applied to this body changes its speed, for example, and as a result produces an acceleration. In rotational motion, the cause of rotation is the moment of the force. Now, only the action of the force F appears on the stationary solid, because the sum of mg and r is 0, and also because they pass through the axis of rotation. So this solid will rotate under the effect of F only, because this force possesses a moment. The moment of this force is equal to F times the distance. Now, since this force is able to rotate the solid, then it is also capable of changing its speed, and thus allowing the solid to acquire an acceleration. Thus, the cause produces an acceleration. The cause, in translation, which is the force F, produces an acceleration. The cause in rotation is the moment of the force, which produces an acceleration as well. But the difference is that the acceleration in rotation is the angular acceleration. The angular acceleration is expressed in radians per second squared. The unit of the moment is the Newton meter. So what is this constant in the expression? This constant is equal to the sum of the moment divided by theta double prime. The unit of this ratio is Newton meter divided by radian per second squared. The Newton is similar to the unit of m times g, for example. Which is the kilogram meter per second squared and multiplied by meters divided by radians per second squared. We can simplify the second squared from the expression, and the radian as unit has no effect. So the answer will be in kilogram meter squared. This unit, the kilogram meter squared, is the unit of the moment of inertia I. The moment of inertia I of this rod with respect to its axis of rotation. Therefore, Newton's second law for a solid in rotation, Newton's second law for a solid in rotation becomes as follows. The sum of the moments of the external forces is equal to I, the moment of inertia of the solid with respect to the axis of rotation, multiplied by the angular acceleration. This formula should be memorized. In this application, consider a homogeneous disk. of mass m equals to 50 grams and radius of 10 centimeters that can rotate around its axis of rotation delta that passes through its center. The disk is subjected to the action of a force of magnitude 0.2 newtons that is tangent to its periphery. In the first part, we have to calculate the moment of inertia of the disk with respect to delta and the moment of F with respect to the same axis. The formula of the moment of inertia of a disk with respect to delta is equal to half mr squared. This is equal to half times 50 times 10 exponent negative 3 times 10 times 10 exponent negative 2. The mass is in kilograms and the radius is in meters. The answer is 2.5 times 10 exponent negative 4 kilogram meter squared, which is the moment of inertia of the disk with respect to delta. Now we have to find the moment of F with respect to delta, which is equal to F times the distance between F and delta. Is the sign of the moment of F negative or positive? F will rotate the disk in the positive direction of rotation. Now what is the distance between F and delta? For this, we draw the perpendicular from O to F. This is obviously equal to the radius. So the formula becomes plus F times R, which is equal to 0.2 times 0.1, which is equal to 2 times 10 exponent negative 2 Newton meter. The second part of the question requires us to draw the forces acting on the disk. So what are the forces acting on this disk? The weight of the disk, mg, and the reaction of the support, and of course the force F. Now to the third part of the question. We have to calculate the angular acceleration theta double prime of the disk. Part 2 is on the figure. We have found that the moment of F with respect to delta, which is equal to 2 times 10 exponent negative 2 Newton meter, and we have also found the moment of inertia of the disk with respect to delta. The moments of mg and r are 0. Then we can apply Newton's second law for a solid in rotation. According to Newton's second law for a solid in rotation, the sum of the moments of the external forces is equal to I times theta double prime. The sum of the moments is the moment of mg with respect to delta plus the moment of r with respect to delta plus the moment of f with respect to delta, and this is equal to I times theta double prime. I is for the system, which is that of the disk with respect to delta. The moments of mg and r are 0 because they pass through delta. And of course, in this application, we are going to neglect friction. Theta double prime equals to the moment of F with respect to delta divided by I, which is equal to 2 times 10 exponent negative 2 divided by 2.5 times 10 exponent negative 4. And this is equal to 80 radians per second squared. This is easy, isn't it? Now the fourth part of the question tells us that the disk starts from rest at t0 equals to 0. So the initial speed, which is theta prime 0, is 0. We have to determine the angular speed theta prime at t equals to 5 seconds. So we have to look for a relation between the angular speed theta prime and the time t. So where can we get this relation from? Theta double prime is constant and positive. So the motion is uniformly accelerated rotational. Let's recall the time equations of the abscissa for uniformly accelerated rectilinear motion and that of the speed. X equals to half at squared plus v0t plus x0, and that of the speed, v equals to at plus v0, also v squared minus v0 squared equals to 2a into x minus x0. Now by analogy, the speed is theta prime, the acceleration is theta double prime, the angular abscissa is theta. And for this one, theta prime equals to theta double prime t plus theta prime 0. And for the last one, theta prime squared minus theta prime 0 squared equals to 2 theta double prime into theta minus theta 0. Let us go back to the conditions of the question to see which equation to use. Theta prime 0 is 0, and we can always eliminate theta 0. Now, if we go back to what's given, we have t, which is equal to 5 seconds. So we use this equation. Theta prime equals to 80 times 5, which is 400 radians per second. This is the angular speed of the disk at t equals to 5 seconds. Now we have to find the number of turns performed by the disk. So we know that one turn corresponds to 2 pi radians, which is an angle. So in which of our equations do we find an angle? So we have to find an angle, then find the number of turns corresponding to the same angle. This angle is equal to 0.5 times 80 times 5 squared, which is equal to 1000 radians. This means that after 5 seconds, the disk would have rotated by an angle of 1000 radians. We write the 1000 radians under the 2 pi to get x, which is the number of turns. X is equal to 1000 over 2 pi, which is approximately 160 turns. Then the disk, under the action of force F and in the absence of friction, performs 160 turns starting from rest.